We're going to continue talking about exponential functions, but we're going to look at something that we call logarithmic functions today as well. And why we're going to talk about that is because exponentials and logs are inverse functions of each other. So one thing that's going to help us, so a logarithm, here's kind of how we define it. It's the exponent to which a specific base is raised to obtain a given value. This will make more sense in a second when we rewrite log functions as exponential and vice versa. So first, let's just talk about some powers. These are ones you guys really want to work on committing to memory, okay? So think about you are multiplying by 2 every time as you increase. Remember, everything to the 0 power is 1. So all of these are, oh, I guess not this one, 1. Okay, so we're doing a few powers of 3, powers of 2, and some cubes that you want to commit to memory, okay? When I'm going through this, like I said, the pattern is I'm just multiplying by 2 every time. You guys probably know most of these, but just double checking, make sure that you do. Okay, so 1 through 7 on the powers of 2, just knowing those is just going to make your life easier, so you don't have to refer to your calculator every time. Same thing with 3s. So this time I'm multiplying by 3 every time. Only a few there. 1 through 4 would be good for you to know for powers of 3s. Things cubed, okay? These are our common cubes. And 256 and 343. Okay, so this is just going to help you with solving exponential and logarithmic equations. Oh, sorry, this is not 256. This is 216. 256 is 16 squared, not 6 cubed. Okay. All right, so here, now this is kind of what I'm talking about. You can help fill in this power. So this is like a blank up here, guys. So it's saying 64 to what power equals 4. Now, notice it's getting smaller. So anytime I'm raising something to an exponent, it gets smaller. There's kind of two options. It could be a negative exponent, or it could be a fraction exponent. So something to remember too is that fractional exponents like exponent, or here, let's write it like this. So something, let's do x to the 1/2. That's the same as the square root of x. X to the 1/3 is the same as the cube root of x. So x to the 1/n is the nth root of x, okay? So fraction exponents allow me to do this. Negative exponents, remember, again, I'm just going to make up something here, is 1 over that value, okay? So that's kind of my way to get smaller values obtained. So 64 to what power equals 4? Well, it's getting smaller. So I want to think about what's my relationship I know between 4 and 64 in terms of powers. And I know that 4 cubed is 64, right? Okay, so because I know that, this is my relationship. So if I want to get from 64 to 4, I need to take the cube root, which is going to involve this. So I need an exponent of 1/3. Okay, cube root of 64 equals 4. We have something really similar going on here. I am starting with 144, raising it to some power to get 12. So I want to think about what's the relationship between 12 and 144. Well, I know that 12 squared, right, equals 144. So in other words, the square root of 144 is 12. So I need to do this. So to write a square root as an exponent, I'm going to use the fraction 1/2. Okay? Sorry, that 2 is kind of hard to see. All right. 2 to what power equals 16? So you can look now up at that list, but hopefully this is a point where you can get things memorized. Okay? 2 to what power equals 30? Well, nothing. So we are actually going to do this without a calculator first. We're going to estimate. Okay, and I'm going to show you how to use your calculator to find this in just a second, but we can actually estimate. So we know some things around that, right? We know that 2 to the 4th is 16, right? And then we also know 2 to the 6th is 32. So it's close, or excuse me, 2 to the 5th. So it's somewhere between 4 and 5, and it's closer to 32, so maybe I say something like 4.8. So x is approximately 4.8. Okay, so I know it's somewhere between 4 and 5, but it's closer to 5 because 30 is closer to 32. Okay, so here is how we're going to use the logarithm. So we're going to see it written as log, L-O-G, that is one function, okay? And this, I must tell you guys, this is saying log base b, this will be a number, of a is x. That's kind of how I read that. Log base b of a is x. Okay, so if I have an exponential function like this, 10 to the third equals 1,000, because they are inverses, the input and output switch places to become a log function. So this says log base 10 of 1,000 is 3. These are equivalent expressions. It's just a different way of writing it. This is called exponential form. And this one is called logarithmic form. Okay, now these arrows, I'm going to fill in some things here. So notice the exponent here is the output here. So that is the power or the exponent. Okay, this 10, we call this the base. Okay, so the base of the exponential function and the base of the log function, those will always be the same when we're rewriting it like this. And then we call this guy, or it's log base 10 of something, we call that the argument. Okay, all right, so let's practice kind of rewriting those. So this one is an exponential. We want to rewrite this in log form, okay? So it is log base. The base is always going to be the same as whatever the base of the exponential function is. So it's going to be log base 5, and then this and this will switch. So it'll be log base 5 of 125 equals 3. And again, you can think about they switch because they're inverses. The input and the output switch anytime I'm looking at two inverse functions. Okay, so this is logarithmic form. Okay, we're going to do the same thing here. So log base here is 25, and then we're going to switch these two. So 5 equals 1/2. So this is the logarithmic form for this expression. Okay, now they're giving me the log form and want me to write it as exponential. So same thing, I look at the base. So 3 raised to the, and then I switch these guys. So 3 to the 4th is 81. And these ones are a little easier, I think, to check yourself because we know, oh yeah, 3 to the 4th is 81. Where if I wrote 3 to the 81 equals 4, I know that's not true, okay? All right, this one, here's the base. So it's 4 raised to the, and then these are switching. So 4 raised to the -2 equals 1/16, which again, I know that's true because that's 1 over 4 squared, which is 1/16. Okay, all right. We're gonna do a couple more estimates here. Okay, so log base 4 of 15. So we're thinking 4 to what power equals 15? That's a good way to think about it. So 4 to what power equals 15? And again, nothing, but we know a couple on either side of that, right? We know 4 to the first is 4. And we know 4 squared is 16. So it's between these two, so it's between 1 and 2, but it's closer to 2. So maybe again, I'd say like 1.8 or 1.9. Okay, so I'm going to say approximately 1.9. Okay. Log base 2 or log base 7 of 52. Okay, again, I'm asking 7 to what power equals 52. So let's think about ones around that. So I know 7 squared is 49, and 7 to the third is 343. So there's a big gap here, right? There's a big gap between 49 and 343. So I definitely want my exponent between 2 and 3, but I want it a lot closer to 2, maybe even like 2.1, okay? All right, log base 2 of 12. 2 to what power would give us 12? Okay, well, 2 to the third is 8. 2 to the fourth is 16. So you might say, oh, 12 is halfway between those, so it's maybe 4.5. But think about this. This is, if I think about these functions, right, it grows faster as I get higher. So I actually probably want, if I want something closer to 16, I probably want something closer to 4 than I do, or excuse me, it's growing slower, and it gets faster as it gets a little bit closer to 16. So I think I'm going to hint just on the other side of that. If you said 4.5 again, we are estimating, guys, so 4.5, 4.6, those are all great, okay? All right, so this one, again, no calculator here. We are going to solve for x. So log base 4 of 16. So think again, 4 to what power equals 16? So I'm kind of thinking about it in terms of an exponential. So 4 to what power is 16? 2. So x equals 2. Okay. All right, here I'm thinking x to the 5th equals 32. So what to the 5th power equals 32? I know that 2 to the 5th power equals 32. Okay, now 3 to the 4th power is x in this case. So 3 to the 4th we know is 81. So for me, you guys, this is kind of how I think about these. I like to put them in exponential form just because those I'm more familiar with. And I think you guys will be as well. Okay, so this one, 125 to what power equals 5? Okay, so notice I'm getting smaller here. So I know the relationship 5 to the 3rd equals 125. So I would know that the cube root of 125 equals 5. So that means x, to get the cube root as an exponent, I got to write it as a fraction. Okay, here x squared equals 25. So x then would have to be 5. Okay, here 4 to the 3rd equals x. 4 to the 3rd is 64. Okay, so again, using kind of our knowledge of powers, that's why it's helpful to have those powers memorized. It makes this part a lot quicker. Okay, so here are some special properties just to know about logs. So our bases are always going to be positive and bigger than 1, okay? If you have log base b of b, it's always 1. So for example, if you had log base 10 of 10, it's always 1. So if these match, it's always 1. Because another way to think about this is 10 to the 1st equals 10. That's why, okay? Anything to the 1st power equals itself. And that's because of this, right? 10 to the 1st power equals 10, okay? Here, log base b of 1 is always equal to 0, okay? So again, like log base 2 of 1 is 0. And the reason is because in exponential form, this is saying 2 to the 0, right? That's always 1. So that's why log base, any base of 1 is always 0. Okay, so we have our most common log is actually log base 10. So you'll hear it called the common log. You'll always, and you often won't see the base written. If you just see the word log, L-O-G, it always means log base 10. If it's something besides log base 10, they will write the subscript for the base, okay? So here is your log button on your calculator, okay? It is right here. Sorry, mine's kind of rubbed off. There's LOG, okay? So we are going to solve for x using logs. Okay, so the thing to think about here is write it in log form first. So I want, think how I wanted to teach this to you guys. So I'm going to show you, if I wrote it in exponential form first, it would be log base 10 of 85 equals x, right? Write it in exponential. So if I do that, so I just type this log button and then 85. And let's go ahead and round to maybe 3 decimal places. So we got 1.929. And these are always, yeah, going to be approximate, okay? So same thing here, if I wrote this in log form. And again, you don't have to write log base 10. You could just write 10, okay, of 1 over 109 equals x. Okay, so log of 1 over 109 is negative 2.037. Okay, here, log of 182 equals x. So 2.26. Okay. All right. So that's just kind of an introduction to log, you guys, and that is it for this video.